Okay, hello students, welcome to my channel. In this session I am going to discuss functions. Okay, in CBSE examination, in function chapter is very important. Relations functions are very important. In functions they will mainly focus on one on two functions. One function, okay, they ask to check whether the function is one or on two. Okay, that means if the we have to check one on two. If the function is both one on two, that function is called as bijective. Okay, these three, okay, majorly they will focus in function chapter. Okay, first we will discuss what is one, or it is also called as injective function. Injective function or one function, both are same. Okay, for example, if f is mapping from a to b, 1 minute, see, f is mapping from a to b. Okay, here what is a is nothing but domain. See, in function chapter, domain and codomains are very important. Here a is nothing but, this is domain, this is nothing but codomain. Okay, see, this is a set and there are b set. There are two sets. In a set, elements are called as domain. Okay, domain, it is also called as preimage. Okay, codomain elements, see, b, this set elements are called as codomain elements. Okay, and whatever the elements belongs to this codomain, that is called as images. Okay, this is very important. Images, that is also equal to range. It's also called as range. Images are, that is also called as range. Okay, you should remember these points. Okay, if you want to say the function is, okay, one function. If you want to say the function is, what is your doubt? Okay, what is your doubt? Ask me. If f is 1 means whatever the elements belongs in domain. For example, x1, x2, x3 belongs to, here some y values are belongs y1, y2, y3. Okay, whatever the elements belongs in this domain, okay, should be mapped to some element in codomain. That mapping is unique. Okay, each and every element, distinct element in domain, should be mapped to single element in codomain. Preimage nothing, domain elements only. Preimage nothing but these elements, the elements which are present in domain, that is nothing but preimage. Okay, preimage or domain elements, these both are same. Okay, for example, if they will give an n natural number, set of natural number to set of natural numbers, these are called as domain. Okay, these are called as domain. This also called as preimage. Okay, is it clear? Domain or preimage, both are same. Images are range of the set, they both are same. Okay, next, what is onto? See, how to check one onto. If you want to check the function is one, see how to check function. Okay, function is one. How to check the function is one. Okay, how to check the function is one. See, if you want to check the function is one, always start with x1, x2, which are belongs to domain. Okay, x1, just consider two elements x1, x2, which are belongs to domain, and start with this function f of x1 is equal to f of x2. If x1 equal to x2, then the function is 1 1, otherwise the function is not 1 1. Okay, this is the method one. Okay, if the same, suppose in MCQ they asked the, see, in MCQs they ask to check whether the function is 1 1 or not 2. Okay, just simply find derivative of that function. If the derivative is greater than 0 or f dash of x is less than 0, then f of x is 1 1 only, 1 1 function. Okay, that means if the function f of x is increasing or if the function is decreasing, then function is 1 1 function. Okay, otherwise this function is both increasing and both decreasing. If the function is both increasing and decreasing, then function is not 1 to 1. Okay, you should remember. Okay, if the function, for example, if some function is given, f is mapping from natural number to natural number, f of x is equal to 2x plus 1. Okay, if we find the derivative of this function, we get 2. Okay, you can consider in place of x, you can substitute any x value. Okay, belongs to natural number, it is always greater than 0. Okay, that means if f dash of x is greater than 0, that means f of x is increasing function. If the function is increasing function, we can conclude that function is 1 to 1 also, 1 to 1. Okay, this is the shortcut trick you can remember. Okay, and another method is how to check the function is 1 to 1. Graphical method you can check by using graphical method also. If the function is 1 to 1, for example, f of x equal to x square. Okay, this is the graph mapping from R to R. Okay, if you draw the graph of this function, okay, if you draw any horizontal line, okay, if you draw the horizontal line like this, if you draw any horizontal lines, if the function, if this horizontal line and the curve intersect more than 1 points, if this curve and horizontal line intersect at more than 1 points, then it is not 1 to 1, not 1 to 1 function. Okay, you should remember this one. And onto function, what is onto function? Onto nothing but if you want to say the function is onto, okay, range of the function that is equal to codomain. Okay, range of the function that is equal to codomain, then the function is onto function. Okay, range of the function that is equal to codomain, then we say that the function is onto. Okay, you should remember that one. Okay, next, see, this is the question. Okay, show that the function, okay, f is mapping. Here mapping is very important. See, what is the domain? This is the domain. Here domain and codomains are very important here. Okay, what is the domain here? Natural number. What is the codomain? This is codomain. Okay, codomain is also a natural number. They are asking to show that it is 1 1 and it is into nothing but if the function is not onto, such type of functions are called as into functions. Okay, we have to show the function is 1 1 but it is not onto, into nothing but not onto. Okay, see how to show it is 1 1. See, natural number to natural number. First start with, see, x1, let to show f is 1 1. Okay, let x1 x2 belongs to natural numbers. Okay, then f of x1 is equal to f of x2. Okay, then f of x1, this is the function. What is the function here? F of x equal to x square. In place of x, take x1, we get x1 square is equal to x2 square. Okay, then take x2 square this side, we get x1 square minus x2 square equal to 0. Then we know that a square minus b square is equal to a plus b, a minus b. Use this formula, we get x1 plus x2. Okay, x1 minus x2 equal to 0. There are two possibilities, x1 plus x2 equal to 0 or x1 minus x2 equal to 0. This is not possible. Why? Because x1 is a natural number. Okay, x1 x2 both are natural numbers. Okay, they never gives 0. They both, sum of those numbers never equal to 0. Okay, then we reject this one. Okay, then we get only x1 equal to x2. This is only possible, x1 equal to x2. Therefore f is 1 to 1 function. Okay, like this you have to show the function is 1 1. Then how to check the, how to prove the function is not onto. See, okay, f is onto or not, we have to check onto or not. Okay, let y belongs to natural number. Okay, you always start like this. Okay, here codomain. Okay, y is equal to f of x. Here let y belongs to natural number, that is codomain. Y is equal to f of x. Okay, what is the function is given? Function is given x square. Okay, in place of x replace y. Y is equal to x square. Okay, then if you take squaring on both sides, we get x equal to square root of y. Okay, x equal to square root of y. See, there exists for all y belongs to natural number. Okay, this codomain y values. Okay, there does not exist. See, x does not belongs to, that implies x is does not belongs to natural number, this domain. See, why because see, in place of y you can see y is nothing but natural numbers, right? In place of y you substitute any values. Okay, example, if suppose y is equal to 2, okay, then x is equal to root 2 we get. Okay, understood? Y is equal to x equal to root 2, but root 2 is does not belongs in natural number. Okay, that means for y is equal to 2, okay, does not exist a pre-image. That means there is no x value. Pre-image doesn't mean there is no x value in domain. There does not exist a pre-image. Does not exist a pre-image. Okay, therefore f is not onto. If f is not onto, therefore f is into function. Okay, like this you should show the function is 1 1 or onto. Okay, is it clear? I think. Next, second one is same. Okay, you see, integer to integers are given. If it is integers to integers, it is not 1 1 and not onto also. Why? Because see, f is from natural, f is from integer to integer, your function is x square. Okay, see, let x1, if you consider any two values from integers domain, okay, then f of x1 is equal to f of x2, that is x1 square is equal to x2 square. X1 square minus x2 square equal to 0. Then apply a square minus b square formula. A plus b, a minus b. Okay, we get x1 plus x2. Okay, x1 plus, see, at least revise some important chapters like relations and functions. Important, only important questions like 1 1 and 2. Okay, how to check relations. Okay, types of relations, symmetric, transitive, okay, reflexive. Okay, definitely they will ask one question for 5 marks or 4 marks, or in 2 marks also they will ask. Okay, and in matrices and determinants, from matrices and determinants you get 10 marks. Okay, continuity, differentiability, differentiation, you get almost 10 marks. Okay, if you study in vector algebra, just revise some formulas. Okay, and in 3D how to find image, shortest distance, okay, shortest distance between skew lines, okay, just revise those type, okay, you get pass. If you revise those chapters, you get easily pass. Okay, it's fine. Then it is x1 plus x2, x1 minus x2 equal to 0. Okay, then see, x1 x2 belongs to integer. There are two cases, x1 plus x2, okay, equal to 0, x1 equal to x2. See, x1 minus x2 equal to 0. Here x1 equal to minus x2, x1 equal to x2. There are two cases, okay, because of this, because integers, because they are integers, x1 x2 belongs to integers, okay, that's why. If you consider x1 is equal to 1, x2 is equal to minus 1, okay, if you apply this condition, we get 1 equal to minus of minus 1, 1 equal to 1 is possible, right? Okay, that's why there are two possibilities, x1 equal to minus x2, x1 equal to x2. Okay, therefore f is not 1 1, f is not 1 1, f is not 1 1. And how to check the function is onto or not? Okay, the same, okay, in place of natural number just take integers, okay, but here you get plus or minus, okay, belongs to integers, okay, everything is same, you get here plus or minus, okay. Y belongs to integer, codomain, but x does not belongs to integer, okay. Example, y is equal to root 2, x equal to root 2, same, these both are same, okay, can use this one. Okay, next this is the question. Show that the function f is mapping from natural number to natural number, f of x equal to x cube is 1 1 into, okay, here also we have to show the function is 1 1 but not onto, okay. In this first one, f is mapping from natural number to natural number, okay, function is given x cube, okay. Let consider, to show the function is 1 1, let consider any two values which are belongs to natural number, then f of x1 equal to f of x2, okay, x1 square, okay, x1 cube, that is equal to x2 cube, then x1 cube minus x2 cube is equal to 0. Apply the formula a cube minus b cube, that is a minus b, a square plus ab plus b square. Apply this formula, okay, we get x1 minus x2 into x1 square plus x1 x2 plus x2 square, this is equal to 0. See, here x1 x2 are the natural numbers. If you can apply, so what if question comes in, sir, what if question comes in mixture of 2 to 3 chapters, then what to do? Mixture means, see, in relation functions they will mainly focus on 1 1 onto, okay, many one, okay, or into or bijective, okay. In relations they will focus on types of relations, okay, or equivalence relation, okay. In matrices, symmetric, skew symmetric, okay, diagonal matrix related questions they will ask. A inverse, in 5 marks question they will ask system of equations, okay, solve the system of equations question they will ask, okay. In inverse trigonometry you should follow the standard process, okay. In differentiation, okay, in differentiation, methods of differentiation, and second and higher order differentiation they will ask. In differential equation mainly there is only for 5 marks they will focus on linear differential equation or homogeneous differential equation only. Okay, in 3D geometry mainly they will focus on distance between skew lines, shortest distance between skew lines. Okay, foot up perpendicular. Okay, such type of questions only they will ask. In indefinite and indefinite integration they will focus on properties of definite integration. Okay, here in this question, see x1 x2 are belongs to natural numbers. Okay, this is positive because of square, this is also positive, this is product also positive. Sum of positive numbers never equal to 0. Okay, that's why only this is only equal to 0. x1 x2 is equal to 0, then x1 is equal to x2, therefore f of x is 1-to-1 function. 1-to-1 function. Now how to check onto function, how to check the function is onto or not. Okay, let y is equal to f of x. Okay, what is the function is given? Function is given f of x equal to x cube. In place of f of x take y is equal to x cube. Okay, then take cube root on both side. Take cube root on both side, we get x equal to cube root of y. Okay, in place of y is nothing but codomain, natural number. Okay, see y is belongs to natural number, codomain. From codomain we consider. Okay, for all y belongs to natural number codomain, that implies x does not belongs to in natural number domain. Okay, why? Because example, you can consider one example. Y is equal to, for example, if you consider 3, you can consider any example, no problem. 5 for example. Okay, this is belongs to natural number. Okay, but x is equal to root 5 does not belongs to natural number domain. Okay, it is in codomain. That means there is no pre-image. There is no pre-image for y is equal to 5. Okay, like this you should show. Same process you can apply for f is integer to integer. F of x equal to x cube is 1-to-1. Okay, it is 1-1 but it is not onto. Okay, this question is very important. See here, domain is given. A is nothing but domain, R except this is nothing but domain. Okay, and codomain is given B except 1, this is nothing but codomain. Very important. Okay, here function given f of x equal to x minus 2 x minus 3. We have to show this function is both 1-1 and onto. Okay, we have to show this is 1-1 and onto. Let x1 x2 belongs to A is nothing but domain. Okay, then f of x1 equal to f of x2. Okay, what is f of x1? x1 minus 2 by x1 minus 3, that is equal to x2 minus 2 by x2 minus 3. Just cross multiply, we get x1 minus 2 into x2 minus 3, that is equal to x2 minus 2 into x1 minus 3. Then multiply, we get x1 x2 minus 3x1 minus 2x2 minus plus 6, that is equal to x1 x2 minus 3x2 minus 2x1 plus 6. Okay, here 6 get cancelled. Then minus 2x, 2 this get cancelled. and this can get cancelled. We get minus 3x1 equal to minus 3x2 and x1 equal to x2. Okay, therefore f is 1-to-1 function. Function is 1-to-1 function. Okay, now how to show onto. How to show the function is onto. See, check onto. Okay, let y is equal to f of x. Okay, what is the function is given? F of x equal to x minus 2 by x minus 3. Okay, in place of x replace y, x minus 3 cross multiply x minus 3 into y is equal to x minus 2. See, this is the function in terms of x. Okay, we have to express the function in terms of y now. Okay, what we get? Multiply xy minus 3y is equal to x minus 2. Then xy minus x is equal to 3y minus 2. Take x common, we get y minus 1 is equal to 3y minus 2. X equal to 3y minus 2 by y minus 1. Okay, this is the x value we get. And see, for all y belongs to b except 1. Okay, there exists x belongs to r minus except 3. Okay, this is nothing but codomain. There exists a y value. Okay, for every y value in codomain there exists a x value in domain. Okay, that means there exists a pre-image that is nothing but domain. Okay, therefore, okay, see, in place of x replace this complete x, f of 3y minus 2 by y minus 1, that is equal to 3y minus 2 by y minus 1 minus 2 by 3y minus 2 by y minus 1 minus 3. Simplify this. 3y minus 2, take LCM, we get like this, by 3y minus 2 minus of 3 y minus 1 by y minus 1. Here also we get y minus 1. This y minus 1 get cancelled. Simplify 3y minus 2 minus 2y plus 2 by, we get 3y minus 2 minus 3y plus 3. Then 3 get cancelled. This is get cancelled. Okay, and 2 cancel, we get y. Okay, after showing like this, therefore f is onto. You should write f is onto. Okay, this is the question. Show that the function f is mapping from r to r. This is very important. And the function is given 3 minus 4x. What is the domain of the function is given? R. What is the codomain is given? Codomain is given R. Okay, we have to show the function is 1 onto and hence bijective. Okay, check 1 function. Check the function is 1 or onto. Okay, first start with let x1 x2 belongs to real number. Okay, that means they both are present in domain. These two values present in domain. Okay, then f of x1 is equal to f of x2. Then f of x1 nothing but 3 minus 4x1, that is equal to 3 minus 4x2. 3 get cancelled, we get minus 4x1 equal to minus 4x2. Divide with minus 4 on both sides, we get x1 equal to x2. Okay, therefore f is 1-to-1 function. Therefore the function is 1-to-1 function. Therefore the function is 1-to-1 function. Now how to check the function is onto? Check onto. Okay, let y is equal to f of x. Okay, what is the f of x here? 3 minus 4x. Okay, see, this is in terms of the function in terms of x. Okay, we need to express the function in terms of y. F of x is nothing but y, 3 minus 4x. Now 4x is equal to 3 minus y, x is equal to 3 minus y by 4. See, there exists a y belongs to real number, it is in codomain. Okay, there exists a x belongs to, there exists x belongs to, x is equal to 3 minus y belongs 3 minus y by 4 belongs to real number. Okay, that is nothing but in domain. Okay, you should write this sentence, this is very important. Okay, that means in place of y you substitute any real number. Okay, there exists a pre-image. Okay, there exists some x value, okay, in domain. Okay, then after writing this one you should write f is, you can write directly f is onto, otherwise you can prove it is f. Therefore f of x is nothing but 3 minus y by 4. Substitute in this one. Okay, wherever x is there, replace this one. Okay, this one we get, that is equal to 3 minus 4 times of 3 minus y by 4. Simplify this, 4 get cancel, 3 minus 3 plus y, that is equal to y. Okay, after writing this, therefore f is onto function. Okay, f is onto function. Okay, next, this type of questions are very important. Show that the function f is mapping from natural number to natural number. Okay, defined by show that the function f is mapping from natural number to natural number. F of x equal to x plus 1 if x is odd number. Okay, x minus 1 if x is even. Okay, we have to show it is 1 1 and onto. Okay, how to show it is 1 1 onto? There are two cases. Even, see, to check 1 1, check 1 1 1 to 1 function. Okay, there are two cases. Case 1, okay, x is even, x is odd, and case 2, x is even. Okay, consider any two values, x1 x2 belongs to natural number. Okay, these x1 x2 are odd numbers. Okay, x1 x2 belongs to natural number. Okay, then what is, if it is x is odd, what is the function we consider? F of x equal to x plus 1. Okay, f of x1 equal to f of x2, then f of x1 equal to f of x2 means x1 plus 1 is equal to x2 plus 1, 1 1 cancel, x1 is equal to x2. Okay, this is the one condition we get. Then x is even, for x is even, okay, x1 x2 belongs to natural number, here both x is even numbers. Okay, then f of x1 equal to f of x2, then x1 minus 1 is equal to x2 minus 1, minus 1 get cancelled, we get x1 is equal to x2. Okay, therefore from here we conclude that therefore f is 1 to 1 function. From here we conclude that the function is 1 to 1. Okay, after that how to check onto, check onto whether the function is onto or not. Okay, let y is equal to f of x. Okay, and what is the f of x? Here also there are two cases. Okay, case 1, okay, x is even, okay, x is odd, x is even, x is odd, and case 2, x is even. Okay, if x is odd, what is the function? What is the function? X plus 1. In place of f of x replace y is equal to x plus 1, then x is equal to y minus 1 we get. Okay, there exists y belongs to natural number. Okay, there exists y belongs to natural number x is odd, right? That means x plus 1. There exists x is equal to y minus 1. Okay, belongs to see here, 1 minute. See, we can see here x is belongs to what? X is belongs to, we can express this as like this. Okay, what is the x value we get? Y minus 1. If x is odd, see, if x is odd numbers, if x is odd numbers, okay, then y is even. Okay, in this case, in second case, f of x equal to x minus 1, y is equal to x minus 1, x is equal to y plus 1. Okay, if x is even, see, if you consider x is even number, y is odd. Okay, here x is we considering even number, y is odd. Okay, then from here x is y minus 1 if y is even. Okay, y plus 1 if y is odd. There are two possibilities we get. Hence from here, if y is a natural number, if y is a natural number contains both even numbers and odd numbers. Okay, there if y is a natural number, x is also a natural number, x is also a natural number. Because y is a even, y is odd, we get both even numbers and odd numbers. Okay, x is also a natural number, that is x belongs to a natural number. Okay, from here we conclude that therefore f is onto also. Okay, if the function is 1 1 onto, such type of functions also called as bijective functions. Okay, you should remember this one. Okay, next this is a question. Okay, I think we done already this question. Show that the function f is mapping from R to R, f of x equal to x cube is 1 1 onto. We done this question, this type of question. Okay, this is also Okay, we do this question. F is mapping from R to R. Okay, your function is given x square. Okay, check 1 to 1, check 1 function. Okay, x1 x2, let x1 x2 belongs to real number domain. Okay, then f of x1 is equal to f of x2. What is f of x1? We get x1 square is equal to x2 square. Then x1 square minus x2 square is equal to 0. We get two possibilities, x1 plus x2, x1 minus x2 equal to 0. We get two possibilities, one x1 plus x2 is equal to 0, or x1 minus x2 equal to 0. From here x1 equal to minus x2, x1 is equal to x2. Because x1 x2 real numbers, we get two possibilities. Therefore f is not 1 function. Okay, because for example in place of x, if x1 I will consider 1, x2 I can consider minus 1, then 1 is equal to minus of minus 1 equal to 1. This is possible, right? That's why there are two conditions are there, because domain is real number. Therefore f is not 1. And how to show it is not onto? Check onto also. Check onto function or not, whether the function is onto function or not. Let y is equal to f of x. Okay, then what is the function is given? F of x equal to x square, y is equal to x square. Okay, see, y is equal to x square, x is equal to plus or minus root y. Okay, you consider any y value. See when this y is defined, okay, when this y value is defined, y value is only defined from 0 to infinity. Okay, y is belongs to only 0 to infinity. Okay, this is nothing but range of the function, right? Y belongs to, this is belongs to, y is greater than or equal to 0, nothing but from 0 to infinity. Okay, from 0 to infinity it can be written like this interval form, 0 to infinity. This is nothing but range. Okay, and what is the codomain is given? Codomain is R. Codomain is given real number. Okay, if range is not equal to codomain, range codomain are not same. Okay, codomain is real number, range is this close 0 to infinity. Therefore range and codomain is not same. Therefore f of x is not onto function. Okay, next this question. F is mapping from n to n. F of x equal to 2x for all x belongs to natural number. Show that f is 1 to 1 and into nothing but the function is, what is the meaning of into? The function is not onto. If you show the function is not onto, that is nothing but the function is into function. Okay, first we have to check the whether the function is 1 or not 1. Okay, let x1 x2 belongs to natural numbers. Okay, then f of x1 equal to f of x2, then 2x1 equal to 2x2, 2 to get cancelled, we get x1 equal to x2. Therefore f is 1 to 1 function. Okay, check onto. Okay, let y is equal to f of x. Okay, y is equal to f of x means what is the f of x is given? 2x. In place of x replace y, y is equal to 2x, x is equal to y by 2. Okay, there exists a y, okay, belongs to natural number. Say for all y belongs to natural number, okay, there does not exist x does not belongs to, say x equal to y by 2, which does not belongs to natural number. Because say for example If you consider y is equal to natural number, y is equal to something, we consider 3. Okay, y is equal to 3, but x equal to 3 by 2, which does not belongs to natural number. It does not belongs to natural number. Okay, that means what is the meaning of this? Okay, for y is equal to 3, okay, does not exist a pre-image nothing but x value. There is no x value for y is equal to 3. Okay, therefore the function is not onto. Okay, therefore f is not onto. If the function is not onto, that is nothing but the function is into function. Okay, like this you should prove. Okay, next this function, show that the function f is from r to r, f of x is equal to sin x is neither 1 1 not onto. See, what is the domain is given? R to r. Okay, say it is the domain is r. What is the function is sin x. Okay, what is the graph of sin x? It is like this. Okay, from minus infinity to infinity. Okay, domain is given minus infinity to infinity. From this, throughout this domain, the function is decreasing, increasing, decreasing, increasing, decreasing, increasing. Okay, it is like a oscillating function. Okay, it is a oscillating function. If it is, the function is both increasing, decreasing. Okay, such type of function is not one to one, from given domain is given r. Okay, if domain is different, we have to check whether it is increasing or decreasing only. If the function is only increasing or only decreasing, then only it is one to one, otherwise it is not one to one function. Okay, what is onto? What is the range of this function? Range is from -1, here from 1. Okay, what is the range of the function? -1 to 1. Okay, range of the function is not equal to codomain. Codomain is real number. Okay, what is the codomain? This is nothing but codomain r. Okay, range is not equal to codomain, therefore f is not onto also, onto function. The function is not 1 1 and not function is not onto. Okay, this much we discussed today. Okay, this is clear.